I'm here again to go over the last topics that we're going to be doing in college algebra. So, yesterday we discussed even and odd functions. We discussed how to find an even and an odd function by looking at their graphs and finding the symmetry, either in the origin for odd or in the y-axis for even. I mentioned that there was also an algebraic test, and that's what I want to work on right now. So from your assignment on Castle Learning, number 9a had this function, x times x minus 3 times x plus 4. I want to first simplify that, so I'm going to multiply out these two first. That becomes x squared plus x minus 12. If I want to multiply the x to x squared plus 4x minus 12, I then get x to the third plus 4x plus 1x squared, sorry, it's supposed to be 1x squared minus 12x. So a simplifies to this function. The test says if you take negative x and you replace that with positive x anywhere here, see what you get. So I'm going to take negative x and replace the x with negative x, raise it to the third power. Plus, I'm going to take negative x again, raise it to the second power, minus 12 times negative x, and simplify that. When I simplify, I get negative x to the third. A negative times a negative is a positive, so this is positive x squared. And then minus 12 times minus x is positive 12x. If these signs are exactly the opposite, I have an odd function. This is an opposite sign. This is a same sign. This is an opposite sign. I have a mixture. So therefore, this is not an odd function. If it were an even function, then they should all stay the same sign, which did not happen either. So in this case, 9a, this function is neither odd nor even. And that's what you use the test for. Another topic that is on the rest of your review sheet is using the law of cosines. So I have this board here that has an example problem, something like some of the problems that are on your page. So my example says, find the largest angle of a triangle that measures 12, 15, and 20 on the sides. If they want the largest angle has to be across from the largest side. So let me just call that A for now. Get a little board space. That I can use here, make it a little larger for you. So I'm going to redraw my triangle. Whoops, it's not going well. I'm going to redraw my triangle. 12, 15, 20. I'm going to call this angle A. The law of cosines says that I need to start with the side for the angle that I either have or want. So 20 squared, I'm calling that little a squared, is equal to b squared plus c squared minus 2bc cosine of the angle that I want. So 20 squared equals 12 squared plus 15 squared minus 2 times my 12 times 15 times the cosine of A. I need to do the math. This is 400. This is 144. 225 minus, if you multiply this out, you get 360 cosine A. Let me stand back so you can all take a look at that. One thing you want to always make sure of is that you do not combine the sum of these with the negative 360. This negative 360 belongs to the cosine of A. So I'm going to subtract 369 from both sides. That gives me 31 equals negative 360 cosine of A. I'm I'm going to divide both sides by negative 360. So the cosine of A is now equal to approximately negative 0.0861. I need the cosinverse of that, negative 0.0861, and if I put that in my calculator, it's going to give me approximately 95 degrees. And that's what that angle would be, 95 degrees. Okay, last topic. Okay, this one's a little bit more challenging. We talked about the sine, cosine, and tangent in their proper quadrants, whether they're positive or negative. But this problem that I'm going to go over with you says if the sine of A is equal to 8 over negative 9, so the sign has to be negative. The sign is negative in quadrants 3 or 4, but they specifically are going to tell us in this problem they want it to be in quadrant 4. So I plot the point 8, negative 9 in quadrant 4. So if I have that problem graphed properly, a point in quadrant 4 is the terminal side. Okay. And so I have to make a right triangle coming out of the origin like this. Here's where my theta would be. So what I'm looking at, let me just blow it up for you, is the point 8, negative 9 here. So that means that the x value is 8 and this guy is negative 9. What we want to do is we want to find out what the cosine of A is. So they gave us what the sine of A is, they want to know what the cosine of A is, which means I need my adjacent over my hypotenuse. That will help me to realize I do not have a hypotenuse. So what do I need to do? I have to find it. My A squared plus B squared equals C squared. The Pythagorean theorem will get me there. So 8 squared plus, now I can put negative 9 and square it, but I can also use positive 9 because it's going to end up positive anyway. This is C squared, so this is going to be 64 plus 81 is C squared. C squared is going to be 145, or C is going to be radical 145. So my cosine of A is going to equal my adjacent, which is 8, over my rad 145. Now when these are multiple choice problems, often you're not going to find it that way. You might want to have to rationalize that function. Which means multiply by the radical over itself. So your answer would be 8 rad 145 over 145. Okay, good luck on the last test of this course on Friday, and I miss you.